Hello, friends. This is a constant motion physics lab presented by yours truly, Lawrence Valdez. Purpose of the lab. The purpose of this lab was to analyze one-dimensional motion at constant velocity using tracker. I extracted position versus time data from a recorded video. I then constructed a computational model, aka glow script, based on Newton's second law and compared the predicted motion to the observed data. Since the object moved at a constant velocity, expected the acceleration to be zero and therefore the net force to also be zero. Physics models and principles, we use Newton's second law and its many different forms, displacement, velocity, acceleration. This was our setup. Motion was constrained to one horizontal dimension, the camera fixed to prevent perspective distortion. Calibration stick used to convert pixels to meters. We had a meter stick and we made sure that the camera didn't move too much. Not too much going on here aside from that. Tracker data. As tracker data is concerned, these were the data entries that I got from tracker. A position versus time graph, which proved to be linear, slope being 0.32 meters per second, motion in the negative x direction, and a very small y displacement. Overall, good stuff. A computational model, aka the glow script. This code uses Newton's second law and a time stepping loop for constant velocity. I set it to zero so acceleration stays zero, velocity constant, and the model predicts a linear time graph that can be compared with our data from earlier. So the assumptions, net force is zero, constant velocity, linear motion, and everything is included in the screenshot. Our data model versus comparison. When plotted on the same graph, the predicted positions from the model match the experimental data. The agreement supports the assumption of velocity and zero net force. Small deviations are likely due to tracking uncertain and measurement limitations. What if, what if? What if we flipped the axes? If the coordinate system were flipped, the sign of the velocity would change, but the magnitude would remain the same. Physical motion itself would not change. Only the mathematical representation would differ. This demonstrates that coordinate choice affects sign, not the physics. Sources of error would include tracker marking precision, pixel resolution limits, frame limitations, systematic errors, camera angle, calibration, scaling, uncertainty, model assumptions, assumed zero net force, assumed constant friction, assumed perfectly 1D motion. Not everything's going to be perfect, and we got our data from tracking video from our phone, so not everything's ideal, but it's close enough. Conclusion, motion was linear, velocity was 0.328 meters per second, acceleration 0, net force 0. Model accuracy matched the data. The motion exhibited zero acceleration, implying zero net force, which is consistent with Newton's second law. The computational model closely matched the observed data, demonstrating that fundamental physics principles can successfully predict real-world motion. Thank you very much.